9th standard ICSE Chemistry Chapter 2, Chemical Reactions and Chemical Changes. Textbook by Prasad. Introduction. Chemical changes occur when a substance combines with another to form a new substance, which is called chemical synthesis, or when it breaks up into two or more different substances, which is called chemical decomposition. These processes are called chemical reactions. Now, there are four main types of reactions: synthesis, decomposition, simple displacement, and double decomposition. Synthesis. Well, when two or more reactants combine to form a single product, a new bond is formed. Decomposition is the opposite: breakup. A single reactant breaks up into two or more products. Now, those products can be elements or compounds or both. Simple displacement. Imagine A and is happy with B, but then comes along C. So A dumps B and bonds with C, simply because C is more reactive than B. That is simple displacement. Double decomposition is an exchange of where they exchange their particles, the mutual exchange of the radicals, that is the ions, between two reacting compounds, and this happens only in solution form, in aqueous state. Now, if oxygen is part of the reactant, then the reaction is called combustion, that is burning. And most reactions also fall under the category of redox reaction, which is reduction, oxidation happening simultaneously, which we'll study shortly. Now, there are some scientists involved in discovery of chemical phenomena. Mark this para as read. Two observations about chemical reactions are: energy is required to break the bonds, and also energy is given out when the new bonds are made. If the energy released is greater than the energy required, then we call it exothermic reaction. And if it's the opposite, we call it endothermic reaction. Example, when you burn hydrogen to form water, it's an example of exothermic reaction because overall heat is released. Whenever anything is burnt in the presence of oxygen, heat is released. Next page. Now let's study synthesis reaction in detail. Mark this as a definition. Now the reactants can be elements or compounds, but the product is always a compound. There is always a gain in mass overall, or it appears to have gain in mass, but actually the mass of the product is same as the total mass of the reactants. Law of conservation of mass says that mass remains same. The reaction is called combination or synthesis. Now let's study some examples. Reaction of metals with oxygen to form oxides. Learn all these equations. Now, color also has to be mentioned, or rather studied, not mentioned. Remember the formulae, which is easy if you know the valencies. Zinc oxide is yellow when hot and white when cold. It's amphoteric, both acidic and basic. This is ferric oxide, it's rust in color, that is reddish yellow. Triferric tetroxide. Copper oxide is black in color. Mercuric oxide is orange in color. Now remember the activity series. It's a list of metals arranged in decreasing order of chemical reactivity. So the most reactive out of these is potassium, the least is platinum. You can remember it with the help of some mnemonic. For example, what I used is KitKat nahi Cadbury mango wala din, जिंदगी फिर भी problematic है, Colgate हटाओ और अपनाओ Pepsodent. Hydrogen is not a metal, but it is placed to know which metals are above hydrogen, which will displace hydrogen from the acid or from water, and which ones won't react with acid or water. Metallic oxides are typically basic, and when it dissolves in water, it forms alkali. Notice that silver, gold, platinum, they don't react with oxygen normally. The reaction of nonmetals with oxygen. Hydrogen will react to form water, but that may require an electric spark. Sulfur dioxide, carbon dioxide, these are acidic. Non-metallic oxides are usually acidic, but some are neutral, like water, nitrogen monoxide. Now, phosphorus pentoxide is also acidic. It dissolves in water to form phosphoric acid. Now, formation of chlorides. Iron plus chlorine gives ferric chloride. It's brown in color. Copper chloride is blue in color. HCl is an acidic gas. This is hydrogen chloride gas. Only when dissolved in water does it form hydrochloric acid. This reaction should take place in diffused sunlight because in darkness it won't take place, and in direct sunlight it is explosive. Also, moisture will act like a catalyst for this reaction. Next, formation of sulfides. Zinc sulfide, iron sulfide, ferrous sulfide is black in color. Silver sulfide is also black in color. That is why silver utensils, silver metal, they turn blackish on the surface because of exposure to hydrogen sulfide gas in the atmosphere. That reaction is similar to the sulfur reaction. Hydrogen, when combined with sulfur, forms hydrogen sulfide, which has a rotten egg smell. Next, nitrides are formed from metals, respectively. If you remember the valencies, you can write the formula easily. For example, aluminum is 3 plus and nitrogen is 3 minus, so crisscross will be ALN. This last equation was very important. This is called Haber's process. It is used to make ammonia gas. It's a reversible reaction. Two gases combine to form a single compound, a new gas. It's a basic gas. That's the only basic gas in our syllabus, and this requires some conditions: pressure, temperature, catalyst, finally divided ion. It's exothermic. Now, higher oxides. Carbon monoxide can become dioxide, and dioxide, sulfur dioxide, can become trioxide, even that is acidic. When dissolved in water, this forms sulfurous acid, but this forms sulfuric acid. Nitric oxide, also called nitrogen monoxide, can form nitrogen dioxide, which is a reddish brown gas. Ferrous oxide can form ferric oxide. Now, if you take a soluble metallic oxide and dissolve it in water, it forms an alkali, which turns red litmus blue. Potassium hydroxide is called caustic potash, caustic soda, and this is called slaked lime. This is called quicklime, this is called slaked lime, and when dissolved in water, it's called lime water. And when you dissolve some non-metallic oxides in water, you get the respective acids. Now, carbonic and sulfurous acids are very unstable and weak, so it's a reversible reaction. Even phosphoric acid is weak, but that's not reversible. Now, nitrogen dioxide is called a mixed acid anhydride because it dissolves in water to form two types of acids, nitrous acid and nitric acid. Now, mark the first sentence as a definition of bases. Some bases are not soluble in water, so they're not called alkalis, but some are, so they are called alkalis after dissolving in water. Acid anhydride means from acid, if you remove water, you get the oxide. Such non-metallic oxides are called acid anhydrides. They will turn moist blue litmus red because they will dissolve in the moisture to form the acid, and acid turns blue litmus red. Next topic is decomposition reaction. Mark the definition. Examples are given. First of all, oxides. Whenever you heat oxides, it decomposes, but that is not true for, say, potassium oxide. The top elements are too stable and the bond is too strong. Heat cannot decompose them. In fact, all these oxides won't decompose. However, some higher oxides may decompose to a lower oxide. For example, here, this is plumbic valencies 4 plus of lead. This is plumbus valencies 2 plus for lead. This is triplumbic tetroxide, which has become plumbus oxide. Mercury oxide and silver oxide are quite weak metals. Their bonds are quite weak. So when you decompose them thermally, we will get the pure metal, which is a silvery residue. And oxygen gas is released, which can be identified because it's a gas which will rekindle a glowing splinter. That's the test for oxygen. And it is collected by downward displacement of water because it hardly dissolves in water. Now, when carbonates are heated, even they decompose, but that's not the case for the first two carbonates because they are quite stable. Although sodium carbonate, washing soda, may lose its water of crystallization, but the carbonate won't decompose. The rest of the carbonates will decompose to give metallic oxide and carbon dioxide gas. Remember, zinc oxide is yellow when hot and white when cold. Copper oxide is black. Lead oxide is reddish brown when hot, no, reddish yellow when hot and yellow when cold. You also call it buff yellow when hot or rust yellow when hot, depending on what your school teacher requires. But the questions in exam will be like, give an equation in which a greenish blue compound decomposes thermally to give you black residue. So you should remember all the colors. Carbon dioxide test is that it turns lime water milky. But that is true for sulfur dioxide also. So there is one more test for carbon dioxide, which we'll study in practical chemistry, that it has no effect on acidified potassium dichromate or acidified potassium permanganate. But SO2 does have an effect on it. Mercury and silver carbonate, well, they decompose completely. They will give you the pure metal, silvery residue. Don't forget the heat signs while writing equations. Carbon dioxide is collected by upward displacement of air because it is heavier than air, and we can't collect it over water because CO2 is highly soluble in water. Now hydroxides, well, again, the first two hydroxides are stable, nothing happens when you heat them. But the remaining hydroxides, when you heat them, it does give you metallic oxide and water is released, and the colors again learn the same. Remember, zinc oxide, lead oxide, and aluminum oxide are amphoric. Otherwise, metallic oxides are basic. Again, mercury, silver hydroxides give you pure metal residue. But how do you prove that oxygen or water has been released? Well, there's a test for that as well. It turns white anhydrous copper sulfate blue. You see, blue vitriol is formed because of water of crystallization. Or pass that steam through cobalt chloride paper. It will turn from pink, blue to pink, proving that the steamy gas was indeed water vapor. Now nitrates, well, when the nitrates decompose, the first two, they do decompose but not completely. They just give the nitrites an oxygen gas. No NO2 is released, no reddish brown gas is released. Whereas in this case, reddish brown gas is released called nitrogen dioxide. Well, even bromine vapors are reddish brown, so if you need a chemical test for NO2, they turn potassium iodide paper brown. Oxygen test we know, and metallic oxides are also formed. Remember, aluminum oxide is white when hot and white when cold. And these we know. In this case, not only are the two gases released, but pure silvery metal is left behind. Ammonium nitrate does not give any reddish brown gas, it just gives nitrous oxide or dinitrogen oxide or laughing gas and steam, of course. Now, when the thermal decomposition is reversible, we call it dissociation. Mark this as a definition. Here, the solid is decomposing to give two gases, which may recombine to give you the solid. By the way, ammonium chloride is a sublimatory substance. Learn both these equations of dissociation. Now, displacement reaction. Mark the definition. Here, a very typical property is that one reactant is a compound and one is an element, and same thing is true for the products. Learn the activity series and even the halogen series. Remember, fluorine is the most reactive. Chlorine is more reactive than iodine, so clearly here chlorine will kick out iodine and combine, and poor iodine is left alone. Here no reaction takes place because magnesium is already more reactive than zinc. An interesting reaction: when you put an iron nail in a blue copper sulfate solution, the solution becomes green because of displacement. Green ferrous sulfate is formed, and the copper kicked out or displaced is deposited on the iron, giving it a pinkish brown color. All the active metals above hydrogen, when you add them to water, they will form their hydroxides or oxides respectively, and hydrogen gas is released. The first three are very reactive, highly exothermic, and they give hydroxides. In fact, potassium sodium reactions are quite explosive. They will dart about on the surface of water. But then the remaining metals, they don't react with cold water. They will react with steam. They will not form hydroxides, they will form oxides. In fact, iron will react reversibly with steam to give triferric tetroxide and hydrogen gas is released. When acids are reacted with metals, salt plus hydrogen gas is released. Lead is not so reactive, so it will react only with hot conc acid. The first three metals of activity series react violently. Magnesium, aluminum, zinc will react even with cold acid vigorously. Iron will react quietly to give hydrogen gas. Below hydrogen, that is silver, gold, platinum, copper, they don't react with dilute acids. You can frame such equations with sulfuric acid also to give salt and hydrogen gas. But nitric acid won't react because it's an oxidizing agent. Instead of giving hydrogen, it will give water. Now, double decomposition reaction. So, both the reactants are compounds and even the products are compounds. They exchange their radicals. Now, if in such a reaction, one of them is a precipitate which doesn't dissolve in water, we call it a precipitation reaction. That's a type of double decomposition reaction. So, mark the definition of double decomposition and precipitation. Water is a universal solvent. It dissolves lots of salts, lots of chlorides, sulfates, nitrates, because they are soluble. Whereas oxides, sulfites are insoluble. Mark this as a good reason. Solubility chart, learn it by heart. It's important from 10 standpoint of view. Remember what kind of salts are soluble in water and learn the exceptions also, which don't dissolve in water. Nitrates are easiest to remember. All are soluble, like no exceptions. Sulfates are soluble, like iron sulfate, copper sulfate, but there are exceptions. Calcium sulfate doesn't dissolve. Barium sulfate, no. Lead sulfate, no. In fact, lead sulfate is white precipitate. Even silver chloride is white precipitate. Lead chloride is white precipitate. But lead chloride is soluble in hot water, not in cold water. Remember that. Now, notice these reactions of precipitation. Remember the colors. Copper oxide is pale blue. So in exam, they can ask for observations. What happens if you add sodium chloride with silver nitrate? You'll see a white PPT. When you write observation, don't write the name of the product. That's not important. The color is important. Here, make a change. It should be NaOH. Reddish brown PPT. Ferric hydroxide. And if it is ferrous hydroxide, it's a dirty green PPT. Remember the colors. Notice how aqueous is mentioned because only in solution state will the reaction take place, will the exchange of radicals take place. Another type of double decomposition reaction is neutralization reaction. Here acid and base react to form salt and water only, no precipitate here. Learn all these equations. Amphoteric oxides and hydroxides, they can react not only with acids but even with bases. So notice that here they are acting like acids because they are reacting with bases to give salt and water only. Learn the formulae and the names. Now some typical properties of acids. Whenever you react an acid with a carbonate or bicarbonate, the products are salts, water, and carbon dioxide gas. Don't write carbonic acid because that's unstable. Instead, break it down into carbon dioxide and water. So if you learn the equation in English, now you can frame any equation. You just need the knowledge of the valencies and the balancing of equations. Now, if an acid reacts with sulfite or bisulfite, and here even nitric acid will give you the same observation, it will give you salt, water, and SO2 gas, because the sulfurous acid decomposes to give SO2 and water. And SO2 not only converts lime water milky, but it also affects acidified potassium dichromate, turning it from orange to clear green, or acidified potassium permanganate from pink to clear colorless. Sulfides, not sulfides, sulfides react with acid to give salt and hydrogen gas, no water here, and this has a rotten egg smell. It also turns lead acetate paper silvery black. Now, some reactions release heat, they are called exothermic. Mark the definition. Because of them, the surrounding temperature rises, and if the surrounding temperature decreases, it's endothermic because they absorb heat. Learn the examples. Values are not important. And every reaction requires a minimum energy to start so that the particles can start colliding with each other. This is called activation energy. Photosynthesis. Here, sunlight is required. It happens only in the presence of chlorophyll. So it's an example of photochemical reaction which happens in the presence of light. This is another example. Now that's why silver nitrate is kept in bottles because otherwise light will decompose it. It's called photochemical decomposition. Reddish brown gas is being released. Mark this as a give reason. When you burn magnesium, magnesium oxide is formed, which is white in color, and blinding white light is released. Learn the observations. When sodium is dissolved in water, it gives out a golden yellow flame because the hydrogen released catches fire, and the sodium vapors give it the golden yellow color. Electrolysis of water requires that some acid is added to water, acidified, because pure water is a bad conductor of electricity. Hydrogen and oxygen are collected at the respective electrodes. Factors affecting rate of chemical reaction. Well, temperature. More the temperature, more is the collision of particles, and more kinetic energy, more faster is the chemical reaction. Particle size, smaller the particle size, faster is the reaction because more is the total surface area exposed. Concentration, more the concentration or pressure, faster is the reaction. These examples are all read. Catalyst mark the definition. They don't take part in the reaction, but they alter the rate of reaction. They may increase or sometimes even decrease. Here, manganese dioxide is a catalyst which is increasing the rate of reaction. So after doing all these markings, in the future, when I give you the homework, chapter review, solve the exercise, I'll even ask you to practice all the equations from the chapter in your chemistry numericals book. Make a separate section for all equations at one place. And you will also be asked to complete all these worksheets, all of them. And you will solve these exercises and the self-evaluation test for homework in the future after finishing the whole chapter.
Hi students, this is AJ sir. If you found this video useful, press the like button. Also, if you'd like to enroll for my test series or online lectures, email me or message me on Instagram. Check my description for more information.